Good day, everyone. Welcome to our final project presentation for Net 313 Advanced Networking.
Today, we will present the Carelink Health Network project, which demonstrates advanced network architecture with DHCP and EIGRP optimization. This project was developed by RJ Sunga,
Jans Lopez,
JC Almario.
and this project is titled Carelink Health Network Design. And now, let's proceed the company overview. Carelink Health is a healthcare provider with three interconnected sites: headquarters, clinic, branch, and imaging branch. The network must support EMR, servers, staff laptops, and imaging workstation with secure and reliable communication. Our goals is to ensure reliable inter-branch connectivity, centralized DHCP, subnetting for growth, and secure access through password. The goal of our company is to have reliable communication and centralized DHCP. Now, for network topology at the center is Carelink headquarters, connected to clinic and imaging via one serial links. Each site has its own LAN with switches and devices. Headquarters acts as a central hub, managing DHCP and routing for all branches. The devices used for Carelink: one router, one switches, one server, one laptop, and three PC for headquarters. And for clinic runs one router, one switch, three laptops, and three PC. And last, for imaging branch, we use one router, one switch, one laptop, and two PC. And now, let's have Almario JC for physical view network topology.
Here, as you can see, this is the physical view of our intercity. Here is the physical view of our city, showing all the branches are connected to the same network. Now you can see the physical view of headquarters with devices such as computer, laptop, server, router, and switches. And you can see the same devices in clinic and imaging. Now, let's proceed to router configuration. Our routers were configured with IP addressing, DHCP relay, and EIGRP. At headquarters, we set up DHCP pool of all sites. Clinic and imaging routers use the IP helper address command to forward DHCP requests to headquarters. EIGRP was chosen for dynamic routing due to its fast convergence and scalability. Now, this table shows the configurations we use for the devices. Here, as you can see, in the first row is the name we use for router. In the second are the interface we use. And the third are the IP addresses. On the fourth are the purpose, and the last is the key commands. You can see the same on the two other branches, in clinic and imaging.
Now, let's configure DHCP on the Carelink HQ router. Since headquarters is the central hub, will be provide IP addresses for all sites: headquarters, stock, clinic, and imaging. First, we exclude the gateway address so they are not assigned to client devices. As you can see, commands that we use are here. This ensures that the first 10 addresses in each subnet are reserved for routers, switches, and servers. Now, we create the DHCP pools to each subnet. Headquarters pool. For the EMR server LAN, we use IP DHP pool and name is HQ pool. And for HQ staff laptops, we use for staff pool. For clinic PC and laptop, we use clinic pool. And for imaging workstation, we use imaging pool. With these pools, configure all PC and laptop across HQ, clinic, and imaging can automatically obtain valid IP addresses, gateways, and DNS setting from HQ. This centralized simplifies management and ensure consistent addressing across the network.
Next, we configure the PCs to obtain their IP addresses dynamically from the DH servers at headquarters. For each PC, we go to the Desktop tab in Packet Tracer, then select IP configuration. Instead of manually assigning an IP, we configure it to DHCP. Once DHCP is enabled, the PC sends a broadcast request. The branch router forwards this request to headquarters using the command IP helper-address. The HQ router then assigns an IP address from the correct DHCP pool. For example, Carelink headquarters PC receive address from the HQ pool with the gateway 172.16.0.1 as well as on Clinic PC. For example, Clinic PC receive an address from the Clinic pool with the gateway of 172.16.2.1. Same goes on Imaging PC that receive addresses from the Imaging pool with gateway 172.16.3.1. This ensures that all devices across headquarters, clinic, and imaging automatically obtain valid IP address, subnet mask, gateway, and DNS settings without manual configuration. Now we configure EIGRP for dynamic routing across all networks. EIGRP was chosen because of its fast convergence and scalability, which are ideal with healthcare that has multiple branches. On each router, we enable EIGRP with autonomous system number 10 and advertise all connected networks. In this case, we use the command router EIGRP10 and input the network. Next is no auto summary, then exit. So after enabling EIGRP, we verify the configuration by typing show IP EIGRP neighbors. Here you can see the two serial ports, the 031 and 030. This confirmed adjacency between HQ, clinic, and imaging routers. Next, we check the routing table with show IP route. Then this will show. This one here shows that each router has learned the routes to the other branches subnets dynamically. The next configuration we have is to secure the network. We configure password on all routers. This includes enable passwords for privilege mode, console, for physical access and VTY password for remote access via Telnet or SSH. On the Carelink HQ router, we use enable secret Carelink 1234, and for the console password is HQ console pass, and for the line VTY we use HQ VTY pass. And same goes on the clinic and imaging router. Next, let's proceed on advanced testing and analysis. In this section, we test the network under both normal and failure scenarios to verify redundancy and resilience. First, let's try to simulate device failure. To begin, we simulate a device failure at the clinic branch. When the clinic router is shut down, the route to the clinic subnet is removed from the HQ routing table. Similarly, when the imaging router is shut down, the route to the imaging subnet is removed. To simulate the device failure, first let's shut down the clinic router. Then, to confirm this by checking EIGRP neighbors using show IP EIGRP neighbors. To confirm this, by checking EIGRP neighbor using show IP EIGRP neighbors. Here you can see that the clinic is shut down and was removed. Let's try to recover this. Now let's simulate for imaging branch. Let's simulate a failure. Then let's try to confirm this using the same command. Show IP EIGRP neighbors. Here you can see that the the imaging branch is no longer here. Now let's store the router.